Hello everybody, welcome to Being Civil. In this video, we will do an example on slope deflection method. In the previous video, we have derived the slope deflection equation. Those who have not watched the video, click this I button here and watch the video first. So here we have a continuous beam AC supported on A, B and C and subjected to this type of loading. We have to determine its support moments and have to draw the bending moment diagram. First you have to write down the equation of slope deflection for the span AB and BC. Let's write down. For span AB, the equation will be MAB equals to MFAB plus 2EI by L 2 theta A plus theta B. Similarly for BA, this MAB, it will be MFBA plus 2EI by L 2 theta B plus theta A. We are not writing the term related to support settlement, that is minus 3 delta by L, because in this question there is no support settlement. Similarly, write down this equation for span BC also. So these are these equations. So now you have to determine the fixed end moments for span AB and BC. You have to keep this formula in mind for the fixed end moment. It is fixed ended beam for UDL loading and fixed ended beam for concentrated. This is W, this is L. So deflection is like this. The moment, this moment will be minus WL square by 12. It is plus WL square by 12. And here it is, let's P. This is A. This is B. This will be PAB square by L square. And here it will be plus PA squared B by L square. So keep this formula in mind. Now we have to calculate these fixed end moments. This MFAB minus WL square by 12 is 5, L is 5, 12, which will be equal to minus 10.42. MFBA will be equals to plus 10.42. MFBC minus P is 10, A 2 to 3 square by L is 5. MFCB equals to plus 2 square into 3 by 5 square. You have to put these values of these fixed end moments into this equation, and you see that this theta A and theta C will be 0 because A and C is fixed ended. So theta A equals to 0, theta C equals to 0. So put these values to these equations. So we have found out these 4 equations, and see, for the equilibrium condition at B, this moment MBA and MBC will be equal in magnitude but opposite in sign. That means that summation of MBA and MBC will be 0. So for equilibrium condition at B, MBA plus MBC will be equals to 0. So at 10.42 plus 4 by 5 EI theta B minus 7.2 to 0. So now put this formula of EI theta V into these equations and get the corresponding moment values. So MAB plus 10.42 plus 2 by 5 into minus 2.0125 minus 11.225 So we got all the moment values. Now it's time to draw the bending moment diagram. So we have find the fixed end moments. This is the beam. And so fixed end moments is the value we got is at point A is 11.225. At point B it is 8.81, and here it is 3.996. It is 11.225. Here it is 8.81, and it is 3.995. So these are the fixed end moments. For this UDL loading, suppose this is simply supported. For UDL loading, what will be the bending moment diagram? And for this one, it will be like this. So what is this value and what is this value? We have to calculate. For this value, it is WL square by 8, and you have to calculate this coordinate also. Here it is 11.225, it is 8.81. So you have to interpolate. So this is 10.0175. So this ordinate will be 15.625 minus ans 5. This portion will be 5.6075. Now this ordinate will be PAB by L, which is 10 into 2 into 3 by 5, which is 12, and calculate this ordinate. So this ordinate will be 12 minus answer 5.116. So this portion is our bending moment diagram. Let us draw it properly. We are drawing the positive bending moment at the bottom. Now what are these values? Hope you have understood this bending moment diagram. If you don't understand, so feel free to ask in the comment section. Thanks for watching. Stay tuned.